What's up, guys? In this video, I will go over the growth and decay questions in exercise 1M. So here we have a patient who is being infected by some sort of virus. So we want to see what is the white blood cells remaining after certain hours has passed. So if you take a look at the steps here, you have to determine if it's arithmetic or geometric. Arithmetic don't quite make sense because you have whole numbers, all of a sudden you have decimals. Right? You just can't subtract numbers that goes from whole numbers and then all of a sudden to a decimal. Okay, so the only other clue is geometric then. So we take the ratio of, let's say, the second point divided by the first point, and then this is a ratio, just to confirm for a few more. Okay, you can check that these are also going to be the same. I checked this beforehand, so you don't have to. Now, creating the general formula, it's a bit weird. So what you can do is, maybe I'll call this W for the number of white blood cells after H hours. You write the initial population, and then in this case, you put the common ratio here, and you want to raise it to the power of H, but not just H, because H is increasing by 12. So that means every 12 hours, so for every 12 hours, you will multiply the population by 0.88. So therefore, this gap here, the gap here, is exactly this number here. This represents the gap. So if this was just like after 0, 1, 2, 3, 4 hours, you can think of this as, H over 1, but that's just H. So you can think of this as an even more general form. So using that formula, we can predict how many white blood cells remaining in after 3 days. So 3 days equals this many hours, 72. So we just want W of 72. So go ahead and input that into your trusty calculator. So around 5,805. I'm just going to leave a whole number. Well, they have decimals there, so maybe I should write down 2 decimal place. MCL. I don't know what this is. I thought this was like milliliter, but then there's a C over there, so it's like millicentiliter, but it doesn't make sense. It's probably like mole times. Oh, is this moles per centiliters? Sorry, that should be CL. I don't know. I don't know what that unit is. Comment below if you know what that unit is. Yes, I know with a simple Google search, I can probably find out. Discuss the limitations of this general formula. Firstly, I will say what I know for geometric, it's just going to be this sort of like infinite series if you just keep going on. So there will be white blood cells remaining all the time. But it shouldn't, right? There should be a stage where the white blood cells should just not be active if they're not fighting anything. Well, there should be white blood cells in your system at all time. But if we just look at this scenario, you can say something like the amount of white blood cells should reach 0 at some point. But this model goes on indefinitely. Excuse my poor writing. Something along that line. Or you can say that the model itself may not be consistent, that you don't really assume that it's just going to be multiply 0.88 after every 12 hours. It could be different, right? What happens if they get infected again? Okay, question 2. So we have an unemployment rate in the US. and it seems to be going down. So this is definitely an arithmetic sequence, right? You can just see it. And that's part A, arithmetic. Write down the formula. So it's just an arithmetic sequence. We have, if I write down U sub n, maybe it's easier to see. U sub n is U1 plus n minus 1d. So instead of UN, I'm just going to call it, well, it is unemployment, so I could call it U sub, let's do month, M. First month is 0.079, so I would just, you could leave it as 7.9, but then your answer will be in terms of percentage, okay? Let's just leave it as 7.9. Plus, this will be M minus 1 times negative 0.2. So all together, it will look like this. And then for C, A, B, C. Use our formula and estimate the unemployment rate in December. So we want 12 months. So go ahead and plug that in for M. 2.4 subtracted into 8.1 should be 5.7. Of course, it's in percent, right? So you should write down 5.7% as a statement there. Is it realistic to expect the unemployment rate to continue to, no, it should not fall below 0%. Because if you keep decreasing by 0.2 and you don't stop it, yeah, it will go to the negative unemployment rate, which could be a good thing, right? Maybe the machines are also, doing so much work that they are not counted as human. All right, question 3, half-life. They actually tell you what it means. Half-life is the time required for substance to decay to half of its original amount. So for A, if a radioactive isotope has a half-life of 1.23 years, that's such a nice number. Explains what this means. After every 1.323 years, the isotope, the radiative materials will the radio will only contain half as much of its original radioactive content. Something along that line. Right, general formula. This one is easy because R is already given. So all you got to do is, well, you need to write down something that's called radioactivity. So initially it will be, we don't know what the amount is. So we will just write down R naught times 0.5 to the power of T, where T, because it's, sorry, this is for every 1.23 years, so it should be T over 1.23. Just like that first example we have with the white blood cells. Use the CDC to sketch the situation. Okay, I know what it looks like. Do we have to? We can't really even sketch it because we don't know where R naught is, right? If you give a R naught meaning here, then it will just half every single 1.23 years. So this will be at 1.23. This will be at 2.46, 3.69. I don't know why my cross is over here. It should be here and it should be there. Oh, let me just do it again. I'm not doing a very good job here. So if I put R naught to be here, half, 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 1.23. There you go. And lastly, for D, if we have a 52 to begin with, okay, how much would it be still after 7.2 years? So we can do R, so 7.2 equals, here we have the original amount, so 52 grams, times 0.5 to the power of 7.2 over 1.23. Which seems to be quite little. Yeah, less than a gram. And this is not what... Did I punch in something wrong? Because that's not what I have in the answer here. The answer key says that it has to be t minus 1, but that's incorrect. Yeah, this is incorrect. Yes, the answer key is incorrect. So it should be 0.899 grams only. The answer key actually subtract this by 1, which they shouldn't do. Because if t is 1, that means after 1 year, then they are right. I was wrong. Sorry. I need to go back and actually fix this. The reason is it only starts decaying after the first year. So if I actually put t over 1.23, when t equals to 0, I actually have, wait, what? No. No, this is correct. Because when time equal to 0, it should be the original amount. So when t is 0, that exponent gives you 1. So then we have r naught, which is the beginning time. After 1.23 years, it should be half as much. So if you plug it into this formula, it works. But if you plug it in their formula, it doesn't work. Yes. All right. Hope you guys learned something, and see you in my next video.